Welcome to P.U.R.E 6. Today we're going to see the question number 2. Obtain macroscopic form of Ohm's law from microscopic form of Ohm's law and discuss its limitation. So before this video, I've already uploaded the question called as derive the expression for microscopic form of Ohm's law. First, understand the concept in that video and then please enter into this video so that we can go in a continuous way. So this question has four subtopics or four divisions where we need to master this topic. The first topic is diagram. We will learn about the diagram. Second one is about the explanation to be given. Third question or third subtopic is about the derivation, which is the main part of this question. And the fourth topic is the limitations of this question. Limitations of this question. So in order to understand the whole topic, we need to see all these four subheadings so that it is easy to understand. So let me go on to the diagram. So I have taken a segment of wire. This blue color is called as, it is not conductor, it's wire. It's a segment of wire. It's a segment of wire. Okay. An enlarged segment of wire or zoom in image of segment of wire. So this wire has a cross section area A. Okay. And now I'm connecting this to a battery which has positive and negative terminal, where a potential difference is set up across the wire, which creates an electric field. Since electric field is being created across the wire, it constitutes electric current across the wire. So first we are going to see the introduction. Introduction is nothing but giving statements about your diagrams and how you're going to start your derivation. So first point you're going to write is, consider a segment of wire. Okay, a segment of wire where A is the area of cross section, area of cross section, and L is the length of the wire. L is the length of the wire. And where V is the potential difference applied. V is the potential difference. You need to mention all these in your answer script so that the examiner who corrects your paper understands whatever you have written. Potential difference applied across the wire. Okay, this is the main four steps that you need to write in order to explain the diagram. Now moving on to the concept based topics or concept based points. Now you need to write what happens when the potential difference is applied across the wire. What happens when the potential difference is applied across the wire? After the potential difference is applied, or when V is applied, electric field is created, which in turn establishes or which in turn establishes or it constitute which in turn constitutes electric current. So first, when you apply the potential difference across the wire, an electric field is created, which in turn it constitutes electric current I. And the direction of the electric field as well as the current is along the same direction. Okay. So this is what happens. So first you need to draw the diagram, then explain all the notations, and then you need to say what happens when the potential difference is created across the wire, and which in turn creates the electric field. After electric field is created, it also constitutes electric current across the wire. So this is your explanation part you need to give. Next we will move on to the derivation part. So I'll also erase the diagram. So next is your derivation. So you need to understand that I'm gonna obtain the macroscopic form from my microscopic form. So therefore I need to state my microscopic form. What what was my answer or final expression in my microscopic form of Ohm's law? My microscopic form was J vector is equal to sigma E vector. This was my final expression in my microscopic form of Ohm's law. Now I'm going to take the magnitude. On taking magnitude, I get J vector magnitude is equal to magnitude of sigma E vector. If you take magnitude, then the vector symbol will vanish and you will be obtaining J is equal to sigma E. So this is your magnitude form. Now, as we saw in my introduction part, whenever the potential difference is set up across the wire, it creates electric field, which in turn constitutes electric current. Now, what is the formula for potential difference? Potential difference is also called as voltage. So what is voltage? Voltage is equal to E into L. How did I get this E into L? That's main topic. So voltage is defined. Voltage is defined as work done per unit charge. Work done per unit charge. Work done per unit charge in order to make the charge move from point A to point B. So my formula for voltage is work done per charge, which is W by Q. So what is my work done? Work done formula is what? Work done is equal to force into distance, right? Fdx or Fx. Force into distance. Now what is force? You are applying force on a charge. You are applying force on a charge in order to make it move from point A to point B. Okay. So the charge is in point A. You are applying a force. You are applying a force on this charge. So what will be the charge? What will be the force on this charge? Force is nothing but you will get it from the equation of electric field. What is electric field? Electric field is equal to force experienced per unit charge. Force experienced per unit charge. So from this I can get F is equal to Q into E, right? So now I can substitute this equation in the place of force. So this is equal to force equal to charge into E. Let me keep this. So I got my equation for force. Now what is distance? Distance is length. In my initial diagram, the length of the wire, the length of the segment of the wire is L. So therefore the distance is also L. Okay. So now I'm going to substitute these two things in my work done formula. So work done is equal to Q into E into L. Now I'm going to substitute this work done formula in my voltage formula. Voltage is equal to W by Q, which is QEL by Q. QQ will get cancelled and my voltage will be equal to EL. Therefore, I can take voltage is equal to EL, or this, right? V is equal to EL. Understood? So I have derived how do I get V equal to EL. So this is not necessary you need to mention in your answer script. Just this is for your understanding. If you want, you can mention so that the examiner will be more clarified in your work. So now moving on, I'm going to get this equation in terms of E. I'm gonna get this equation in terms of E so that I can substitute this obtained equation in the place of E in the current density form. So if I want to get this equation in terms of E, I'm gonna transpose this L to LHS. So when you bring a quantity which is in multiplication to the left hand side, it will become in division. So E is equal to V by L. So my E value, E is equal to V by L. Now I'm gonna substitute this equation. In which equation? Equation number 1. This is my equation number 1 and this is my equation number 2. So substituting equation 2 in 1, J equal to sigma into V by L. So I get this equation. This is my equation number 3. Now what can I say? What is current density? Current density is defined as the current per unit area of cross section. Current density is defined as current per unit area of cross section. So this will be my fourth equation. Now equating 4 and 3. So equating 4 and 3. What will I get? I by A is equal to sigma into V by L, right? Now I'll bring this equation in terms of voltage. So V is equal to, when I transpose this sigma and L to the LHS, it will become I into L. So this is not capital L, this is small l. I made a mistake here. This is a small l. So when I bring this sigma and small l to the left hand side, it will become I into L by A into sigma. In this equation, L by A into sigma is called as resistance of the conductor. Resistance of the conductor. So that wire which I took in blue color is also called as a conductor since it allows current to pass. So it is called as resistance of the conductor. So from this, what can I say? R is equal to L by A into sigma. Let me keep this equation in this place. So in the place of L by A into sigma, I can substitute R. So my equation will become V is equal to I into R. So this is my macroscopic form of Ohm's law. Now I need to give some statements or definition for macroscopic form of Ohm's law. So before moving on to that, I'll just say two important things. Since I got R is equal to L by A into sigma, I can get two amplification, or which is R is directly proportional to L and R is inversely proportional to A. The first thing is the resistance of a conductor is directly proportional to the length of the conductor, and resistance of a conductor is inversely proportional to the area of the conductor. In examination, you should put a note. You should write it as note. You should put these 2 points in the subdivision called as note. You just need to mention L by A into sigma is the resistance of conductor, and then you can substitute R is equal to L by A into sigma. Then you should put a note and you need to explain that R is directly proportional to length of the conductor and R is inversely proportional to the area of the conductor. This is the main, this is an important topic. You need to mention these 2 points so that there is no reduction of marks in your answer. So now moving on to the statements of macroscopic form of Ohm's law. So this equation, let me take this equation as equation number 5. So my equation 5 is called as macroscopic form of Ohm's law. So how can I state macroscopic form of Ohm's law? It is defined as, it can be stated as the potential difference across the given conductor is directly proportional. Is directly proportional to the current current flowing through the conductor. Current flowing through the conductor. Okay. So the potential difference across the given conductor is directly proportional to the current flowing through the conductor or current passing through the conductor. You can either write current flowing through the conductor or current passing through the conductor. So the final expression for this statement will be V is directly proportional to L. V is directly proportional to L. Sorry, V is directly proportional to I, not L. V is directly proportional to I. So this is your statement for macroscopic form of Ohm's law. And from this equation, what can I say? Resistance. From this equation, I can say that resistance of a conductor or resistance is defined as the ratio of voltage across a conductor to the voltage across the conductor to the current flowing through the conductor. Current flowing through the conductor. So this is the statement for macroscopic form of Ohm's law, and this is the statement for resistance of the given conductor, which is resistance is defined as the ratio of voltage across a conductor to the current flowing through the conductor. So from this equation, from phi I can write. So fifth equation can be written as R is equal to V by R. So ratio of voltage across a conductor to the current flowing through the conductor. So this is the equation for resistance. So this is the last step of the derivation. Next, we will be moving on to the limitations of this microscopic form of Ohm's law. So what are the limitations? How do we say that? So limitations contain a graph where you need to express or you need to express or represent this whole topic in terms of graph, which will have current versus voltage graph. So till now we have seen the answers of three subdivision, which is diagram, introduction and derivation, and this will be my last topic or last subtopic of this whole derivation, which is called as limitation. It is called as limitation. So what is the limitation of this macroscopic form of Ohm's law? So before stating the limitation, I will draw a graph. Where my x-axis will be voltage and my y-axis will be current. The graph between y-axis and x-axis is a straight line. Is always a straight line. Okay. So this graph is representing current versus voltage. This graph is representing current versus voltage, and the representation of graph is in the form of a straight line. So this is a linear graph where the slope is reciprocal or it is inverse of its resistance. So a graph between voltage and current will always be a straight line, and its slope will be the inverse of the resistance or reciprocal of the resistance. So for example, if the point here is 5 and this is also 5, and the first point is 5 comma 5, the second point is 7 comma 7, second point is 7 comma 7. How do you find the slope? Slope is equal to y2 minus y1 x2 minus x1. So this y2 minus y1 will be taken from y-axis, right? Will be taken from y-axis divided by x-axis, right? So what is the quantity in y-axis? Current, which is I, divided by what is the quantity in x-axis? Voltage, which is V. So slope is equal to I by V. So what is my resistance? Resistance is nothing but V by I. But I have I by V, which is nothing but 1 by R. 1 by R is equal to I by V. 1 by R is equal to I by V. So which is nothing but reciprocal of resistance or inverse of the resistance. Now comes the limitation. So a conductor. So a material can be conductor if it allows current to pass. If it allows the current to pass. Now, if the material of the conductor has a, or what in other terms, what I can say is, if the material whose current versus voltage graph is a linear graph and has constant resistant value, if the material has linear graph in current versus voltage and also has constant resistance, then it is said to obey Ohm's law. Okay, this is one of the advantage or merit point. Okay, but the main limitation is, and the behavior of this material is called as ohmic behavior. Okay, and the opposite of this ohmic behavior is called as non-ohmic behavior, where the material will not have a linear graph and will also not have constant resistance value. So if a material does not satisfy the condition for I versus voltage graph, that is if it does not have a linear graph and also if it does not have constant resistance, then the material is not obeying Ohm's law and it is said to be non-ohmic behavior. So that is the only limitation of this whole topic. Therefore, I'll write that point also. Material which does not have linear graph. What is this linear graph? Linear graph is nothing but a straight line graph. Linear graph, and also does not have constant resistance. Then it is not obeying Ohm's law. Then this behavior is called as non-ohmic behavior. So this is the only limitations that you need to write. So this is a merit point and this is a limitation point. So I'll write clearly. If they ask you to write the limitation of this question, you are requested to write only about non-ohmic behavior and you should not write the ohmic behavior in the part of limitation. If you want to mention ohmic behavior, just write above the limitation part. Don't write it inside the limitation part. So this is the end of this question. So in this question, we saw the diagrammatic explanation, the introduction, which was containing the explanation of the diagram as well as the starting step of the derivation. Then we saw the derivation. After that, we saw the limitations, which contain the graph and the merit point as well as a limitation point. Mostly in examination, they will ask limitation as well as to obtain the expression for macroscopic form of Ohm's. So this is it. We will meet you in the next video, which will be a very important topic, which will be revealed later.